So now we're going to approximate the area under the curve using 4 equal subdivisions and determine if our answers are overestimates or underestimates. So since we're looking for 4 rectangles, that means n equals to 4. So delta x, which is the base of each rectangle, is b minus a over n, which is 5 minus negative 3 over 4, 8 over 4, which is 2. So that means we're going to start at negative 3. And we're going to jump by 2's to create those intervals for the base of each rectangle. And if we see, that makes 1, 2, 3, 4 equal bases. So now if we're using left-hand Riemann sums, we want to approximate that area. So each base is 2, and then the first left-hand side I would plug in would be 3, and so that's h of negative 3. Plus 2 times h of negative 1, plus 2 times h of 1, plus 2 times h of 3. So that would be our 4 heights coming from our 4 bases on the left side. So now if I plug in to my function, I can approximate the height from the graph. I'll factor out a 2. At negative 3, my height's about 1.9. At negative 1, the height's about 3. At 1, the height's at 7. And at 3, the height's about, let's say, 8.1. So that was going to be unit squared because it's area. And this is an underestimate because h of x is increasing. So we could simplify this answer, but we're not. Let's move on to the right-hand side approximation. So a of r is approximately 2 times h of negative 1 now, starting from the right side of that first interval, plus h of 1, plus h of 3, plus h of 5. So using the right-hand interval, it's 2 times 3 plus 7 plus 8.1. We know that from above. Plus h of 5, which is about 9 from the graph, unit squared. And this is going to be an overestimate for the same reason, because h of x is increasing. So we can use left and right Riemann sums to estimate the area under a curve.